Okay, so last week in lab, you split water by electrolysis. So what I would like you to do is to complete or to label this diagram. So what's happening, which electrode is the anode, which one is the cathode, what is the half reaction which occurs at each electrode, and then how much voltage, or what is the minimum voltage required to split water. Okay, so you guys done? Yeah. Okay. So, would you add anything to the water? And if so, what did you add to the water?
Salt. Acid or base.
Yeah, acid or base. So what acid did you use? Sulfuric acid. What base could you use? Okay, so would someone like to show their cell diagram of their electrolysis using sulfuric acid on the chalkboard? I thought you guys just told me you were done. And now I'm asking for a volunteer and no one wants to volunteer. Okay, I'm asking for a volunteer. I'm not asking for the class to force one person to go up there to succumb to peer pressure. Okay, good to see you.
There you go.
There you go.
I like your jersey.
I like your hair.
Okay, can you describe the half reaction that occurs at each electrode?
The half reaction.
And so far so good, you showed that H2 is produced at the cathode, O2 is produced at the anode. So what is the half reaction, that is the oxidation reaction and the reduction reaction which occurs at each electrode?
You want that equation? Is that?
I think so. Now you have the right equations, but there's a little detail. George.
For the anode, since it's being oxidized, it should be 2H2O that goes to O2, 4 plus, 4H plus 4 electrons.
Yeah, because you want to show the reverse.
Then the reverse, just change the arrows.
Then what about for the other reaction?
Reaction, you flip it the other way.
Yeah, so you want to show the reverse of that reaction. Okay, so what is the minimum voltage required to split water?
1.23.
And how'd you get that number?
It's great. The ESO thing.
So ESO, you use 0 minus.
Okay, good. Any questions for Stephen? Now, you also said you can do this in sodium hydroxide. So does someone want to show their cell diagram using sodium hydroxide on the chalkboard? Okay, well I guess that means we're moving on. Okay, so let's move on. You do this in lab. You plated, I see, did you silver plate an iron spoon? Well, I know you zinc plated a copper penny. So, which electrode would be the copper penny? The anode or the cathode? Okay, so if you wanted to, okay, so in this case here you want a silver plate, a iron spoon. So is the spoon going to be the anode or the cathode in this reaction? Okay, so let's pretend that we'll say that this is the iron spoon, and what would you use as the electrolyte? Yeah, so you want silver ions in this solution, so you could use, for example, silver nitrate. This is your iron spoon. So what reaction do you want to occur at the iron spoon? Yeah, reduction of what substance?
Silver ion.
Yeah, so at the silver spoon, you want the silver ion to be reduced to silver metal. So that means that the iron spoon, is that going to be the anode or cathode? That's going to be the cathode. Okay, because the cathode is where reduction occurs. And we want reduction to occur. We want the silver ion to be reduced to silver metal. Okay. Let's do this one. We haven't done this one yet. 100 milliamps of current is passed through the cell for 30 minutes. Calculate the mass of silver that's plated onto the spoon. And here's two formulas you can use. I, which is current, which is equal to Q divided by T. And then Q, which is charge, is equal to N times F. So let me write these equations now. So current, which is I, that's equal to Q, which is charge divided by time. So note that Q is in coulombs. And then time is in seconds. And then the second formula is to Q, which is charge. And that's equal to N, which is the moles of electrons times Faraday's constant. So N, this is the moles of electrons, and then F is Faraday's constant. Now Faraday's constant comes from the charge of an electron, so the charge of one electron is 1.6 times 10 to the minus 19 coulombs, and then multiply that by Avogadro's number, and this is how you get this 96,500. Okay, so let's see, what information are we given? Yes, so we're given the time, which is 30 minutes. And what other information are we given? Yeah, we're given the current, which is 100 milliamps, or 0.1 amps. Okay, so based on these two pieces of information, can we calculate the mass of silver that's plated onto the spoon?
Yeah, just solve for Q. Get coulombs.
Yeah, so note that we have current and times we can solve for coulombs. Once we know Q, we can solve for N. This gives us the moles of electrons. Once we know the moles of electrons, what's the next step? We want to know the mass of silver. So how do we go from moles of electrons to mass of silver?
Use molar mass of an electron.
No, so you said that in the solution there's silver ion. Okay, so we know that the reaction would be a silver ion plus one electron, and that produces one silver. So note that the mole ratio is that for every 1 mole of electrons which are passed, 1 mole of silver is plated onto the spoon. So once you know the moles of electrons, can you calculate the moles of silver? Then once you know the moles of silver, can you calculate the mass of silver? Okay, so can you do that calculation? Okay, so again, you know current and time, so you can figure out Q. Once you know Q, you can figure out N. And then once you know N, which is the mole of electrons, you can calculate the moles of silver. Once you know the moles of silver, you can calculate the mass of silver. Okay.